Hello and welcome. This is Andre, and in this video I'm going to present a lesson that's about transport and how a city can create a better network of transport for its citizens. The backstory for this lesson is that the town council or the city council has made a plan for the city to adopt more bicycling routes, and to do that they need to first of all create a path that goes all the way through the city, a bicycling path, and to connect it all, bridges across the canals. And this lesson actually focuses on the bridges and how we construct bridges and some of the math around building the bridges. So I'm just going to demonstrate how we actually work with bridges. Along with this, students will also get more accustomed to how bridges actually bring value to an urban environment, and by studying cases before they go into Minecraft, they get a deeper knowledge and understanding of how this works. So the scenario, as we've seen before, is that they come into a meeting of the city council, and the students are architects and constructors. So what they see on the boards here are some of the challenges in the city on the agenda, and what they see over here, I'll just jump onto the table, is some of the possible solutions to these problems. And the solution that we're focusing on is the creating better bicycling facilities. So students will grab a map here, and this in order to find the different building sites. So beforehand, students will be given a specific building site. So this is pre command blocks, so this is actually quite good because students will be able to work with coordinates and find their location by navigating with coordinates. Yeah, I'm a coordinate junkie. So this is what they do. Let's go down here, and they go out, and over here we've just provided a bit of service to give them the general direction they need to be going. So let's just try and go over here to bridge number 2. So let us see over here. What we've done is actually build the bicycling path. If you've ever been to Denmark, this is a very normal thing in an urban environment, is that there's bicycling facilities for cyclists all over the place. So this is where the bridge has to be, and the students are tasked to build this bridge. Now, they don't just go in and start building away. There's certain restraints to the bridge, such as how much it can slope. So they have to be aware of actually exactly how much it slopes. So let me just demonstrate. In the student material, I have some screenshots that explain this to the kids. Oh, I shouldn't be using gravel for this. Let's just use some of this. If we do this, for example, we go, if the slope, it goes one horizontally and one up vertically, then we have a slope of 100%, or I suppose it's called the inclination coefficient. I don't actually know the English term for this, but we definitely introduced the formula to work this out. So we can work with this kind of a slope, or we can say a slope of 50%. It goes 2 out the x-axis and 1 up the y-axis. So students need to be aware of how they are building, and obviously they can't build this steep because they won't be able to bicycle up it. So they'll probably also have to look at their bridge over here and say what's the average slope of this bridge, and work that out. So they have to build a bridge that goes from here, to here, and as you can see, the cycling path goes on here. So they have to not only build on the x and the y axis, they also have to build on this axis. So they have to create a structure that moves on 3 axes, which is actually quite a challenging task, because I had some of my students do this, and they ended up spending quite a bit of time actually getting the slope right. Another thing that another restraint we've put on the bridge is the relation between how much there is for pedestrians and how much space there is for bicyclists. And the restraint we've put on is a 60-40 ratio. So that means that if you have, say, 7 blocks, a 7-block wide bridge, the ratio of 3 for pedestrians and 4 to cyclists fits, sort of, which is where the grass here represents the 40% and this here represents 60%. So they'll also have to be wary of the what do we call it, the cross section of the bridge as it goes over to the other side. So these are the restraints that we're putting on to this structure, and the last restraint is the height of the bridge. It has to be 5 blocks high at the minimum. So this is just one site. Let's just go over here. All the sites are unique. Okay, let's just go over here and take a look at another location just to see how another example of how a bridge, or where a bridge has to be built. So there's an optional start here, and on the other side there's also another starting point. So here the group has to create a bridge that goes over here, and that's just an example of that there's different kinds of locations, and the path just goes through the whole city, connecting the whole city. So that part is done. So that was basically it, and thanks for watching. Bye.